All right, so here is the second part of the 7.4 notes that we'll be going over. So other example, we have a 25-foot flagpole that casts a 42-foot shadow. What is the angle that the sun hits the flagpole? So again, let's draw ourselves a picture. So I'm going to kind of just put it right about here. So we have, see, a flagpole, 25 feet right there. And then it casts a shadow that is 42 feet right here. And I'm just going to kind of draw in the angle. So let's just pretend that this kind of dotted line is the angle that the sun is basically kind of like the line of light emanating from the sun. All right. So what is the angle that the sun hits the flagpole at? And so we've drawn our picture. We have 25 feet. This is a 90-degree angle. We have 42 feet that the shadow casts, and we want to find the angle that the sun hits the flagpole. So first off, we need to ask ourselves, what angle is it really asking us for? So an angle that the sun hits the flagpole. Well, it's not this angle down here, not this one down here, by the 42 feet. And a lot of people would say it's this one right here. However, it's not. It is actually this angle out here. Again, it's the sun that it hits the flagpole. So it's essentially sun to the outside of the flagpole, which is right here. And then again, this is the inside because this is the shadow side of the flagpole. So it is actually hitting the outside part, this angle. All right, so I'm going to go ahead and erase the inside here. Darn it. So I'm going to erase all this. Because again, we are only interested in this angle right here. But as I look, I have a 25-foot right here, 42 feet. I have a right triangle, obviously. But my angle is not inside of the triangle. So how can I even solve for that? Well, one thing that we hopefully all should know is that if we look at the angle of a straight line, we know that any straight line, if you draw an angle on it, it is going to equal 180 degrees. Okay? So, and now looking at the rays of sun that are going through the flagpole, we can see that and I know it's not a straight line, but it would be a straight line, that this entire angle right here would be equal to 180 degrees. So again, the angle outside of the triangle and then the angle just inside the triangle, all of that together should equal 180 degrees because it's a straight line coming off the sun. All right. So now I'm hoping you can see where we're going with this. We can solve for this inside angle and then take that, and then we can take 180 minus this inside angle and then get this outside angle. All right, so let us see here. So we're dealing with this angle right here. Let's just call it angle, I don't know, let's just call it, angle A or whatever. All right. Now, solving for angles, we're going to be dealing with our inverse trig. We're going to get our inverse trig ratios: sine inverse, cosine inverse, tangent inverse. All right. Looking at this angle A, I still need to, actually, I'm going to rename it. I'm going to rename it to angle B just for not to cause any confusion. So again, this is angle B. So going to rename it to angle B. Apologize for that. Now we need to determine our side lengths, our known side lengths. We know our 25 feet and our 42 feet. Again, our 42 foot is opposite of our angle B right there, so that's our opposite side. And then 25 feet is adjacent because it is the side that is touching, that is creating the angle there, so that is our adjacent side. We need our inverse I already said it, but we need our inverse trig ratio that deals with opposite and adjacent. And again, that is our inverse tangent, all right? So we're going to do tangent to the -1, that's tangent inverse, and then in parentheses, we're going to do our opposite over adjacent ratio. Again, if we were just doing regular tangent, we would put the angle measurement. But because we're trying to find the angle measurement, that's why we use tangent inverse, and we put the 42 over 25 in the parentheses. Okay. So again, if we solve for the tangent inverse of 42 over 25, we would get that would equal to 59 degrees. So we know that angle B here is 59 degrees. And again, going back to, and again, that's not the angle I'm looking for. I'm looking for this outside angle right here. And again, if I know that this straight line here is 180 degrees, then I can take 180 minus 59 and get this angle that the sun is hitting the flagpole at. So I'm going to go ahead and do that. I'm going to take 180 minus 59. Solve that out. That gives you 121 degrees. All right. So again, the sun hits the flagpole. Go up. So this angle, again, right here, the sun hits the flagpole at 121 degrees. All right. All right, last example. So Elise is standing on top of a 50-foot building and sees her friend Molly. If Molly is 30 feet away from the base of the building, what is the angle of depression from Elise to Molly's feet? Remember, Elise's eye height is 4.5 feet. Let's draw a picture. So let's draw a building like this. And then let's draw Molly. Again, this is not to scale at all. In fact, I'm going to erase this a little bit. Again, pictures don't have to be to scale. I apologize that this one is not exactly to scale. So here's Molly. I'm going to write an M for Molly. Then Elise, who's up here. And it says Elise's eye height is 4.5 feet. So we know that from about here to here, it's 4.5 feet. And it asks for what is the angle of depression from Elise to Molly's feet. Now remember that the angle of depression is again from the horizontal line of sight, which is right here on her eyes, and then the angle that creates looking down. So it's essentially going to ask for, so pretend that she's looking down. Again, it's the angle of depression, so she's going to be looking down. So it's going to be asking us for this angle right here. Again, a lot of people would want to say it's this angle right here, but it's not. This is the angle we're solving for. Yes. Yes for yes, no for not solving this angle. Because again, the angle of depression, this is your horizontal line of sight up here, okay? And then it's essentially when you look down, it's the angle that your line of sight, when you look down, creates with the horizontal line if you would have looked straight out. If you were to solve for this angle is asking for the line of sight from her, the angle from her line of sight to the building, and that's not what we're looking for here. All right. And so let me label this again. We have this as a 50-foot building, and that Molly here is 30 feet away. All right. Now, there are a couple of ways that we can solve for this. There's a couple ways we can solve for this. Number one, we notice that this horizontal line of sight up here and the ground are parallel to each other. Again, this line up here and this line down here are parallel to each other. All right. Because these lines up here are parallel to each other, we know that this angle right here, I'm going to call it angle M for Molly. This angle right here, angle M, and the angle of depression from Elise's horizontal line of sight looking down would be equal to each other because they are alternate interior angles. Alternate interior angles are anytime you have two parallel lines. I'm going to say alternate interior angles, AIA. You have two parallel lines. If you have a line that kind of connects them, then this angle here and then this angle here would be parallel, would be equal to each other, as well as this one equal to this one. All right. So again, I know that's a little confusing for that right there, but just know that M right here and up here would be parallel to each other. All right. Another way we could solve for this would be that we can notice that, well, look at this. If I'm going straight, I got a horizontal line that's going straight out here, and then the building is going straight up and down. Well, I know from that this angle right here is one giant 90-degree angle. All right, so I can solve for this angle, which I call E, up the angle up by Elise up here, and then I can take 90 minus whatever this angle would be. Again, it's whatever you feel most comfortable with. I'm gonna try to set up both of them here. So again, say we're solving for angle M right here. Solving for angle M right here. All right. Let's go ahead and label our sides. And now a lot of people would say that, oh, it's 50 feet would be my opposite side. It's 50 feet of this total. In fact, it is actually going to be 50 plus 4.5 because, again, we want to find, because, again, if we look at our triangle connects from Molly's feet. I know it kind of goes to Molly's body, but Molly's feet up to Elise's eyes. So we want to find, so again, the total triangle length over here, instead of 50 feet, is actually 54.5 feet. Because again, the triangle that we're dealing with goes up to Elise up here and not just the base of the building. If it was the base of the building, if we were just dealing with the base of the building, then yes, we would be 50 feet. But because they added in the eye height of 4.5, we need to do 50.4.5 times plus 4.5 up there. So solving for M, this 50.45 is my adjacent, is my opposite, 30 is my adjacent. I'm solving for an angle, so I'm going to use an inverse trig ratio. Well, I would need to do a trig ratio that deals with opposite over adjacent, that is tangent again, so we'll do tangent inverse of 54.5 over 30. That's a 5 right there. If you solve for this, you should get that angle M down here is 61 degrees. And again, by definition, these are both this angle right here and then this angle up here are alternate interior angles. So that would mean that our final answer, that the angle of depression would be 61 degrees. So that would be our final answer. But let's also look at solving it the other way. Let's solve for let's see, angle E up here, and then find this angle by taking 90 minus angle E. So again, opposite and adjacent would essentially flip. So our 30 down here, I'm going to erase it actually. Our 30 feet down here would be our opposite, and our 54 would be our adjacent. Solving for E up here. So going down, it's essentially the same ratio, tan inverse, the same trigs, tan inverse. This time we're going to flip it. It's going to be 30 over 54.5. Solve for that, you should get 29 degrees. If you solve for that, and then if you again try and solve for our angle of depression out here, again, that is going to be 90 minus angle E, which is 29. So again, 90 minus 29 degrees, that gets us 61 as well. So again, those are the notes for 7.4. I have already posted the 7.4 practice set as well as the Unit 7 practice set as well. For those of you that want me to perhaps go over these notes in class tomorrow when we hopefully come back to school, we can do that. If not, tomorrow and Wednesday are just going to be review days for you guys to work on to prepare for your for 7th period test on Thursday, and then for 6th period test on Friday. That is all. Have a great day, y'all.